Hello, viewers. Welcome to the lecture series of number system, and this is your lecture number 4 for number system. And today we are going to see some more problems based on number system. In the last lecture, lecture number 3, we studied about divisibility test. We saw a couple of problems based on it. So today we are going to mainly focus on unit digit. So let's get started with the problem number 1. Which of the following can't be units digit of a perfect square? So first of all, you need to understand that what is a perfect square. So a perfect square is a number which is obtained from a number multiplying with itself. For example, 4 is a perfect square because 2 square gives us 4. 25 is a perfect square because 5 square gives us 25. So when do we say a number is not a perfect square? Suppose 7. You cannot have a number which when squared, integer, which when squared gives you 7. Okay, so that's is perfect square for you. So let's see the solution to the problem. It's quite simple. Unit digit of a perfect square cannot be 2, 3, 7, 8. So option number B is correct. You just have to remember this, that these number don't have perfect can we not be unit digit of a perfect square. Okay, so the option number B is correct here. So moving on to problem number 2. Units digit The digits unit place of the product 81 times, 82 times, 83 times, and it goes till in 89. So we have to find the unit digit in this number. That means when I multiply this number and I will get a number, correct? An integer will be obtained. So we have to find the unit digit of that number. So what will be the number? So if you go on multiplying this number, it's not a smart move because it will take a lot of time and your time will get wasted. So let's see a short, quick method to do that. So if you play a little bit smartly, you will observe that in this number we have 82 and after 84 we have 85 as well. And you know that whenever you multiply 82 and 5 at a unit digit, you will always have a 0. So after you have a 0 in the unit digit, whatever number you multiply, the unit digit will always be 0 only. So that means, or not considering 2, I can also say that whenever you multiply 5 with any even number, your unit digit is going to be 0. So here we have 82, we have 85, and when we multiply 2 into 5, the 0 will be there at the unit place. So now if you multiply any number to that number, 0 will always remain at unit digit. So your answer should be A, option number A, that is 0. So let's move to problem number 3. So what is the unit digit of this huge number that is given to us? 217 to the power 413 into 819 to the power 547 into 414 to the power 624 times 342 to the power 812. So how do you find the unit digit at this product? We need some method. And now you have to recall what was the method to find out the unit digit at any given for any given number. So the rule that will be used here is, here you have for 7, use that. Here you have 9, here you have 4, and here you have 2. So the rule will work accordingly. So what is the rule? So if the number is 7 in the unit digit, then if you divide the number in the power with 4, okay, and remainder turns out to be 1, then the unit digit will be 7. If the remainder is 2, then the unit digit is going to be 9. If the remainder is 3, the digit is going to be 3. And if the remainder is 0, then the unit digit is going to be 1. And so, when you divide 413, this number, by 4, the remainder will be 1. So that means the unit digit for the first number, unit digit for the very first number, 217 to the power 413, it is going to be 7. Okay. Now, next number, we have 9 as a unit digit. And for that, we know if 9 to the power x, and if x is odd, in that case, unit digit will be 9. And if x is even, the unit digit is going to be 1. So the for second number, 819 to the power 547, the unit digit is going to be 1. Correct? For 414 to the power 624. So here we have 4 as a unit digit. So for that, the rule will be if x is odd, then the unit digit will be 4, and if x is even, the unit digit is going to be 6. So the number here in the power is 624, and which is a even number. I hope you know what are even numbers and odd numbers, because we have already discussed it in the lecture number 1 for number system. If you don't know, I would suggest you to just have a quick revision of that video or check out that video. So the unit digit here will be 6. For second number, we have 342 to the power 812. And for that, the rule is if the remainder is 1, the unit digit will be 2. If the remainder is 2, the unit digit will be 4. And if the remainder is 3, the unit digit is going to be 8. If then the remainder is 0, the unit digit is going to be 6. So now, since the unit 812 divided by 4 yields 0 as a remainder, so the fourth case is going to work. Since we now know the unit digit for each of them, we can simply put them and multiply it. And on multiplication, you will get a number whose unit digit is going to be 8. So the final answer is 8. So the option correct here will be option number D. Moving on to problem number 4. The unit digit of 137 to the power 13 to the power 14. That's a tricky question. Looks like a tricky question, but it's not. If you know the results well, then you can do it very quickly. So let's see. So first of all, what we are going to do is we need to just separate out the things. We need to focus on some part of the problem, and then we will move to other part. So first of all, we are going to solve this much part only, neglecting the 47, the power 47. We will be neglecting it, and we will work on this part only. So for now, 7 is a unit digit, and what will be unit digit in this 137 to the power 13? We will are going to solve that first, and later we will move to the original problem. So as usual, we just saw the result. If 13 is there, okay, so when you divide it by 4, when you divide 13 by 4, yeah, the remainder is going to be 1, correct? So in that case, what we have seen, if remainder is 1, then your unit digit is will be 7. So unit digit is 7. So now you know that the unit digit of this number is 7. Now you have 7 to the power 47. Now again apply the same rule. Divide 47 by 4, and the answer you will get here is 3. Okay, so that was a not so tricky problem. One may get afraid of by looking so many powers together, but it's not. So the answer will be B. Option number B is correct. Problem number 5. So if x equal to 164 to the power 169 plus 313 to the power 337 minus 727 to the power 726, then what is the unit digit of x? So again, we have a huge number, and we have to find the unit digit of this number. So we are going to solve it individually. So first of all, we are going to find the unit digit in this case. Next, we will find a unit digit in this case. And later, we will find a unit digit in this case. And once we are done with that, we will add all of them and check the unit digit in new number that will come out after doing this addition and subtraction. So when you divide the power 169 by 4, you will get some remainder, correct? and according to that remainder, you have to identify what will be the unit digit. Similarly, do for 313 to the power 337, divide 337 by 4, you will obtain a remainder and find out for that remainder what is the unit digit for that if the remainder is that. And similarly do for 726. So once we are done with that, so the unit digit for the first part will be 4, for the second part will be 3, and so the third part will be -9. And on simplification, you will get 8. So the option correct here is C, that is 8. All right, let us move ahead. Find the unit digit of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus dot dot dot, and it goes till 333, 4 times 3 factorial. Okay, so how do you do it? Let's see a quick short trick. You have to just use your brain. If you look at the problem here, 5 factorial. Okay, so what is the value of 5 factorial? So 5 factorial is 120. And now, whatever number you see, after 5 factorial, suppose 6 factorial, 7 factorial, all of them contains 5 and an even number, correct? This case is always going to arise. So that in that case, as we have seen in the previous questions, if you have 5 at the unit digit and an even number in the other number, even number unit digit in the some another number, and if you multiply them, you will have 0 at the unit digit. So after 5 factorial, all of them is all of them will have 5 and a even number at the unit digit, and once we multiply it, you will have 0 at the end. So for example, if we check 4 factorial, it is 24. If you see 5 factorial, it is 120. If it is 6 factorial, so how do we write 6 factorial? 6 into 5 into 4 into 3 into 2 into 1. So you have 5 here, you have 2 here. So this thing will give you 10, and 10 will make sure that in each and every number you have a 0 as unit digit. So for example, if you go for 7 factorial, 7 factorial will be 7 into 6 factorial. So now 6 factorial also have 10. So this number will also have 10 at the unit digit. If I say 11 factorial, 11 factorial can be written as 11 into 10 into 10 factorial. Okay, and 10 factorial have 0 at its unit digit, correct? So 11 into 10 factorial will also have 0 at its unit digit. So now one thing we have observed is after 5 factorial, each of them, if each of the number will have 0 at its unit place. So those number are not going to contribute anything in the final result. So whatever the value we get for this sum after 4 factorial, the number after 4 factorial, the sum of 5 factorial plus 6 factorial plus so on is not going to contribute anything to the unit digit because it is 0. That means the value of unit digit completely rely on this number. So now if I know the value of this, if I can compute the value of this term, I will be able to easily find out what will be the unit digit. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, and 4 factorial is 24, which gives 4 as a unit digit. Just quickly have the sum, it will be 13, and 3 is the unit digit of this number, correct? So your final answer will be 3, that is option number C. I hope you understood the question well. So now we have problem number 7. What is the unit digit of 1 factorial to the power 1 factorial, 2 into 2 to factorial to the power 2 factorial, and so on? So can the similar thing work out here? Try to think. We will be having here 4 into 4 factorial to the power 4 factorial plus 5 into 5 factorial to the power 5 factorial, correct? And the list will go on till this number. So this will have 0 at its unit place because 5 factorial is equal to 120, and 120 to the power anything will have 0 at the unit place. If I multiply 5 to that, in that case also you will have 0 at the unit place. Same thing goes for all the numbers. Okay, that means again after 4 factorial, the numbers after 4 factorial are not going to contribute anything to the final answer because after 4 factorial the unit digits are 0 and it will not change the value. That means this part will only this part is going to help us compute the unit digit, correct? So what you have to do is simply compute this thing, this thing, this thing, and this thing. Identify the unit digit. What is the unit digit for all these small parts? Okay, we have broke down the problem to small parts. Solve them, and you will have 1 for the first part, 8 at the unit digit for the second, 8 as the unit digit for third, and 4 as the unit digit for fourth. And if you take the sum here, the sum is going to be that will be 16 plus 5, that is 21, and 1 is the unit digit here, so option number D should be correct, that is 1. Okay, let us move to problem number 8. Again we have a product of numbers in which we have to identify what is the unit digit. Again, we are going to break down the problem into smaller pieces. We first going to identify the unit digit for this number, then we are going to identify the unit digit for this number, and at last we are going to identify the unit digit at this number for this number. Then we will have the product for those unit digits and take the unit digit of resultant product. So for this number the unit digit will be 4. How we calculate the unit digit, I don't have to tell this because we have already solved a lot of examples in which we find the value of unit digit for this number. Simply divide 1793 by 4 and check the table that we have created. Okay, so 4 is going to be for this one. For this one we will be having 5, and for this one we will be having 1, because whenever you have unit digit 1, and whatever times you may multiply it, 1 will always be there at the unit digit. Now just multiply this will be 20, and 0 is a unit digit. So option number A is correct. Now problem number 9. We have to find the unit digit in the sum of these two numbers. Again, divide this number into two parts. Divide this problem into two parts. First of all, find the unit digit. First of all, find the unit digit for this thing. Okay. Later, find the unit digit for this thing. Okay. So for 124 to the power 372, we will be having unit digit 6. Okay. And for second part, 124 to the power 373, the unit digit is going to be 4. So if you take the sum, you will get 10, and 0 is a unit digit in 10. So the process is listed down here. We have already seen this process in the lectures. So that's the theory part for your problem. You can have a quick glance over it if you don't remember it. Okay. So this is the problem number 9 for you, and the final answer is D. Okay. Now let's move ahead and see problem number 10. The digit at hundreds place value of 17 factorial. Now they are not asking the unit digit, they are asking the hundredth place value. Okay. So we know that after 5 factorial, we get 1 0 at the end of the number. Correct? We have already seen such examples. A lot of examples have been already discussed, so I think I don't have to explain it again. We can say that 7 factorial, we get minimum 3 zeros, correct? So the 100th place will be 0, correct? So that will be option number B for you, 0. Let us now move to problem number 11. So what is the unit digit of 1 to the power 5, 2 to the power 5, plus 3 to the power 5, plus dot 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 20 to the power 5? Here, one interesting thing to note here is whenever a number is given to you, whatever number it is given to you, and if you take the fifth power of that number, the unit digit will always turn out to be the same number. That's a very interesting result and it's very beautiful. So for this, for 1 to the power 5, unit digit will be 1. For 2 to the power 5, unit digit will be 2. For 3 to the power 5, unit digit will be 3. And 4, 5, 6, 7, 8, 9, unit digit is going to be 9. For 10, unit digit is going to be 0. Or for 11, unit digit is going to be 1. For 2, unit digit is going to be 3. For so on. So till 20, you can write this down. Okay, let me repeat the result. Whatever number is given to you, if you take the unit power of if fifth power of that number, then the unit digit will be same as unit digit in the original number. For example, if I give you 200, suppose 9, and I take fifth power of this, so unit digit here is 9. So the final result, the unit digit will be here is 9 for the fifth power of this number. Okay, I hope you get this. So this is a very interesting and amazing result that we have used here. So just you have to do simple computation, add them, you will have 45 plus 45, that will be 90. And in 90, the unit digit is 0. So your answer should be option number B, that is 0. Let us look at the last problem for this lecture, that is problem number 12. Let x equal to 633 to the power 24 minus 277 to the power 38 plus 266 to the power 54. What is the unit digit of x? So again, we will break down the problem into smaller parts. You first find out the unit digit in this number. Secondly, you find out the unit digit in this number. And last, calculate the unit digit in this number. Once you have that, it's very easy to compute. So for this one, this part, unit digit is going to be 1. For this part, unit digit is going to be 9. And for this part, unit digit is going to be 6. And on simplification, you will have 8 as your final answer. So therefore, the correct answer is A, option number A, that is 8. Okay. So basically, if I have to summarize each and everything, any huge number will be given to you. It can be in the product, it can be with some addition sign, subtraction sign. Break down the problem into parts, find out the individual unit digits, then compute whatever sign is given to you according to that, and check the unit digit in the final number, final result you have obtained. That's exactly what we have done here. Okay, so that would be all for this lecture, and do practice more and more so that you can increase your accuracy and do problem faster. Thank you very much.